He is a professor of gerontology at the University of Southern California. He knows that many things live fast and die young, and he believes the road to reversing entropy in the body starts where things get the hottest, in the engine.
In the engine, the gasoline gets oxidized, and that's a combustion process, and this provides energy to the car. But because of the combustion, the engine itself can become damaged, and eventually you have to rebuild the engine.
Every cell in our bodies have tiny engines called mitochondria. Mitochondria are double membrane structures whose job is to provide energy. But when these powerhouses wear down, our body begins to decay and age.
And so you can imagine in the cells instead, you have hundreds of these mitochondria, these little engines, and these hundreds of engines provide the energy locally to every single cell in our body.
But Walter has found a way to reverse this deterioration process and rejuvenate mitochondria in one tiny organism. He has extended the life of baker's yeast, the kind you use to make bread and beer, to 10 weeks. That's 10 times the yeast's normal lifespan of 6 days. It may not sound like a long time, but it's equivalent to 800 human years. The yeast's longevity occurred when two genes, RAS2 and SCH9, were removed from its DNA.
So these pathways that we've identified in yeast, in addition to promoting aging, they also promote DNA damage and the damage of a variety of different systems within the cells.
Walter wondered if this fountain of youth for yeast might apply to more complex life forms. And so he began looking for the equivalent genes in a much larger organism, mice. When he knocked out those two genes, these mice doubled their life expectancy.
This is very encouraging because if you look at the similarities between a mouse and a human, we're over 90% identical in many ways. The mouse lives for 2 years and people live for 100 years. So you can see with just a small modification of the genome, you can go from 2 years to 100 years.
There's no law of physics that prevents us from finding the secret of longevity, the secret perhaps even of immortality. If you take, for example, the genome of millions of old people and the genome of millions of young people, which we will do in the coming years, and subtract, you will then find the genes where aging is concentrated. Already, we've identified over 60 genes involved in the aging process.
Now the question is, how do you reprogram a human that lives 100 years to be now a 2,000 or 3,000 year old person?
Walter's mission to keep our engines running forever has just begun, and he's in it for the long haul. Suppose we do find a way to keep our engines running for hundreds of years or more. We would all be very old for a very long time. But this scientist is digging for ways to keep us not just eternally alive, but eternally young. Take our current lifespan and stretch it 5 or even 10 times longer. The joys of our youth would endure like an endless summer. But imagine suffering decade after decade with fragile bones, failing eyesight, and an ever more feeble mind. If we want to become immortal, we can't just extend life. We need to discover how to keep our bodies eternally youthful. Aubrey de Grey thinks of himself as a modern-day Methuselah. He has dedicated his career to fighting aging. Aubrey believes that many people who are born today could live to be 1,000 years old and remain physically young for most of that time. The key is a matter of good biological housekeeping. taking the trash out of our cells.
So what happens indeed is that certain types of material in the body just accumulate junk. Certain types of junk accumulate inside cells and between cells, and stuff that we would not think of as junk, like DNA, accumulates randomness, which is a type of junk.
Cells have the important job of constantly breaking down waste, and they're mostly pretty good at it. But sometimes a cell comes across things that are so weird, none of its degradation machinery works on them. That's when the junk is rerouted to what's called the lysosome, the vessel that houses the most powerful degradation machinery in the cell. And if the garbage can't be broken down, it stays there forever. Aubrey believes that the accumulation of garbage in the lysosomal storage unit is what causes aging. And he wants to free our bodies of these buildups. He realized the most logical way was to take a close look at waste itself. And he wondered, in nature, what likes to eat junk?
We're working on an idea that we might be able to find other species, especially bacteria, that are able to break down these substances that accumulate in the human body.
Aubrey's hunt for the fountain of youth led him to a final resting place: graveyards. Since graveyards are riddled with the waste of decomposing bodies, he suspected he might find microbes who live to feast on death.
And if we can find the genes and enzymes that they are using to actually perform that function, then we might be able to put those genes and enzymes into our own cells so that our own cells can break stuff down that they could not naturally break down.
The secret to longevity might be 6 feet under. Aubrey and his team are still digging for the right microbe that will work in mammalian cells. And when they find it, he believes we will all live like 25-year-olds forever.
I think that we have maybe a 50-50 chance in the next 25 years or so of developing what I think of as the first generation of bona fide rejuvenation biotechnology. In other words, technologies that are sufficiently comprehensive that we can give them to middle-aged people 60 or 70 or so, and fix them up well enough that they don't become biologically 60 or 70 again until 30 years later or something like that.
Aubrey is looking for the magic bullet that will fight aging, but synthetic biologist Chris Voigt is looking to build an entire army out of various parts from all over nature.
All right, let's give this a shot. One of the things we're often trying to do in synthetic biology is create new functions out of parts that already exist in nature for other reasons. So we're often having to go out and grab those components from different organisms and put them together.
Chris searches for microorganisms throughout biology to find the right part.